Thank you, sir. Thank you very much. Sir, is it visible, sir? Hello? Okay, sir. A very good evening to all. This is Rajyalakshmi from Department of Physics, Adikavi Nannaya University, Rajamahendravaram. Today, I would like to discuss about rare earth materials and its applications in daily life. The main points we are going to discuss are introduction, classification, global production, elemental properties of the rare earth materials, applications of rare earth materials, and news which are related to these materials, and conclusions, the way forward. What are rare earth elements and why they are important? So before we are going to discuss about these rare earth elements, so what are the elements which are present in this periodic table, or what are the elements which are present in our universe? Let us let us discuss a small thing. And if you see the water daily, which is very important to survive of the life, or in the universe, water is very essential element. And if you consider these water, we have, it contains a hydrogen and oxygen, that means H2O. That means if you see any material and which we are sir, uh, actually, just introduction part, no, sir. I did not represent any slide here. Just okay. So just this is a simple basic elements I am going to discuss, sir. And if you see, we are using the ornaments in our daily life, and gold, aluminium, and all these represents the different elements which are related to these properties which are in our universe. We have, and if you see the atmosphere also, it consists of different elements. That means carbon dioxide, which has two elements, combination of two elements, carbon and oxygen, or nitrogen, and all these elements. And if you see, different types of elements are there in our universe. But why I am choosing these rare earth elements? Because it has a vast importance, and it has a vast applications in our daily life. So let us discuss about these rare earth elements and how they are applicable in our daily life. Let us see. And see here, this is the periodic table of elements. We have hydrogen. Already we have, I have told you about water, H2O, hydrogen and combination of oxygen. And here we have from hydrogen to up to 1 or 3 elements we have. Hydrogen, helium, lithium.
Excuse me, ma'am. I'm sorry, excuse me.
Okay.
Slides are not moving, ma'am. Slides are not moving.
Slides are not visible, sir.
Slides are visible but not moving, madam.
Okay.
So please do it. Go to the proper page.
So is it there periodic table of elements, sir?
No, madam. The first slide is there. No, the introduction, your introduction slide is there.
Okay. Just wait, sir. Now, once see, sir. Not there, sir. Not
yet. Not yet.
Okay, just. Okay. Just wait. Sir, is it visible, sir?
Yes, ma'am. It's visible. Now you are on the page about rare earth elements.
Once wait, sir. Just wait. Sir, now, sir, is it moving, sir?
Yes.
Is it moving? Is it moving, sir?
Yes.
Slides are moving.
Yes.
Okay.
Yes.
Okay. So periodic table of elements. Sir, is it visible? Shall I continue, sir?
Yes, madam. Okay, no doubt. Please continue.
Okay, thank you, sir. Thank you. So these are the periodic table of elements. Here we have different types of elements. Hydrogen, already we have discussed about water, H2O. So hydrogen, it is the first element, and oxygen, it is the 8th element. So we have different types of elements, but here I have chosen only the rare elements. Why? Because so only we have 17 elements. That means from 57 to 71 and 21, 39. These two elements are also comes under the rarest elements. So why? Let us discuss about these elements briefly. The slides are not moving. Just wait, sir. Here, slides. Sir, is it visible now? No? Hello?
No, madam. It will take some time. No.
No, just this one. I will show you, just wait. Sir, is it visible? Just so shall I explain, sir? It is not showing. Okay. Just. Sir, is it visible, sir? Sir, is it visible?
It will take some time, madam.
Okay. Sir. Okay. Sir, is it?
Now it's visible, madam.
Visible, sir. Periodic table of elements.
Yes.
But
don't be hurry, madam. Don't be hurry. Go slow.
Okay, sir.
We will understand more. Topic is very important.
Okay.
Yes, ma'am. It's moving now. Please continue.
Okay. So here we have 17 elements. So let us discuss about these elements. And periodic table of elements, total 17. From 57 to 71, lanthanum to lutetium, and 21 and 39, these are scandium and yttrium. Actually, here we have 57 to 71, only 15 elements are there. But these two elements, which is 21 and 30, we have considered these two elements also rare earth elements, because these exhibits the properties which are exhibiting the 15 rare earth elements. That's why we have total 17 rare earth elements. From lanthanide, here this is the lanthanide and this is lutetium. So these elements which exhibit the properties are similar, the properties which are exhibited by this scandium and yttrium. Next one. So why are rare earth elements given their name? Actually, the name itself we have rare earth elements, but these metals, they are not rare on earth, but here we can observe they are spread very evenly over the earth. It is very difficult to extract, and it is very difficult to find a lot of a single element in one place. That's why the name it is given as rare earth elements. But actually we have the worldwide, we have a lot of rare earth elements, but it is very difficult to extract the elements, and it is very difficult to find the elements. So simple basics about rare earth elements. So up to 1940s or even 1960s, we don't have any rare earth metals, because no one discovered about these rare earth metals. But in 1965, the major applications for the rare earths are included. That means if we observe the mixtures of the rare earth oxides, these are used for the polishing lenses and the mirrors. And the cerium and lanthanum, these oxides which are used in the zeolite catalysts for petroleum refining. And the alloy which is known as mish metal, which is used for the plates for the lighters. So these are the major applications which we can observe in the 1965. But up to 1940s or even 1960s also, no one discovered about these rare earth elements. So here we have total 17 chemical elements which are represented these rare earths. But out of these, these elements are classified into light rare earth elements and heavy rare earth elements. So what is the difference between these two elements means? So it has a vast thing we have, but it is very difficult to understand. Simply I will explain you what are the light rare earth elements and what are heavy rare earth elements. So light rare earth elements which are lowest atomic number, and heavy rare earth elements. So comparatively, these relative to these lowest atomic numbers, so little bit heavy or higher atomic numbers. So these are the two main differences. So based on these things, and that means lowest atomic numbers and highest atomic numbers. So classified we can into two types of rare earth elements. So this is 4F elements which is present in the light rare earth elements. So these are the different metals with the already which we have discussed these rare earth elements, and the number of 4F electrons which consists for these each and element, and number of 4F electrons unpaired electrons for these different elements. So this is a little bit difficult. So I am skipping this explanation because it is not understand in a single session. So simply these are the abbreviations. RE means rare earth, REM rare earth metals, REE rare earth elements, REO rare earth oxides, and REY rare earth elements and yttrium. LREE light rare earth elements. Already I told you light rare earth elements, heavy rare earth elements. So LREE, HREE. So these elements are classified with scandium, lanthanum, cerium, and etc. And heavy rare earth elements, yttrium, terbium, dysprosium, homorium, erbium, like this. So these are heavy rare earth elements, and these are the light rare earth elements. So let us discuss how the names has given. So up to 1960s, we don't have any rare earth elements. So after that, scientists, they were trying to extract these minerals, and they have discovered the different properties of these elements. So based on the scientists who discovered after their period, the name has given. And some of the elements which have based on their geographical discovery, the names has given. So just I will tell you simply of 2 or 3 elements. So scandium, if you see, so this is the name which was given from the Latin scandula, which is Scandinavia, which was given for this element, and this is scandium, which is used for the light aluminum scandium alloys for aerospace components. So we have so many applications for each and every element. And so if you see this yttrium, so it was the name was given after the village of Ytterby, Sweden, so where the first rare earth ore was discovered. So based on these geographical discovery, or the scientists who discovered based on these properties, also they have given different names, and these are the applications. So yttrium, which was used in lasers, and yttrium aluminum garnet lasers we can use in televisions, and different so many applications we have. And cerium, and these nandium, neodymium, all these elements have which was came from Greek or precious, like this different geographical element. Based on these areas also the name was given. And all these elements which are these are all the applications for these elements. And let us discuss the importance of these elements. So here, rare earth elements which are essential part of many high-tech devices. So regularly we are using cell phones or computer hardwares or electrical hybrid vehicles. Today we are using hybrid vehicles, which has the most expensive, and these elements are used in these hybrid vehicles. Hybrid vehicles means which we can use multiple options. That means we can use gas and also petrol or diesel, multiple. So works in multiple applications. So these rare earth elements are used in hybrid vehicles and flat screen monitors, light emitting diodes, LEDs, medical imaging televisions. So these are all different applications which we are use these rare earth elements. And let us discuss the production. So where we are obtaining this production, let us discuss. And global production and its demand of rare earth minerals. So global production in tons annually, which is 1,33,600, but global demand we have 1,30,000 tons annually. So this much of production annually will be done, and demand 1,30,000 almost, which the materials extracted almost we are using this much of demand also we have. So this is the estimated 2 crores tons annually by 2035. So this is the which estimation only. 3,50,000 tons annually by 2035. This much of usage can be will be there in future by 2035. And this is the distribution of rare earth production worldwide as of 2025 by the country. So here we can see Vietnam, Brazil, Thailand, Russia, India. We are production very least, that is 1.23% only. So out of these countries, China, here we can observe up to 57.57%. This is the which up to, in 2020s the China, which is production which is very high, 57.57% of the production is there. But second place United States, and Burma third place, and India here very least, almost very least 1.23% of this production worldwide analysis. And here worldwide economics resources for rare earth elements, and here this is the countrywide. We can see China, United States, Australia, India, Malaysia, Brazil, and others we can see. So rare earth oxides we can see here, rare earth oxides we can see from China, very more number we can see here, and India a little bit, only 3% percentage of worldwide, only 3% only we can extract. Sources of we can see 3% source from India. And here rare earth elements mining, the India opportunity. Currently, China dominates the world reserve of rare earth elements. So even though China it produces 57.7%, but it has a restriction, ban is there, because China it uses these rare earth elements in the weapons. So that China have some restriction to export these rare earth elements, even though it has a lot of production. So China bans to export these rare earth elements because they are using in weapons. So it is very dangerous for our entire world. That's why it has a ban. So this has forced the other countries to look to India. So even though China has high production, because of this ban, so overall world it looks to India, because in Asia, so in the Asian region we can supply. That means India can supply for all to all the world. So India it has a total of 1065 million tons, which reserves in rare earth metals. And see, so which rare earth elements are found in India. So even though we have 17 rare earth materials, so India mostly we have monazite. That means this is the main rare earth mineral which is found in India. So however, it contains radioactive thorium which cannot be stored in. So even though monazite it is a material, so we can extract thorium which is radioactive thorium, but we cannot store this radioactive thorium. So that's why so much of monazite which cannot be mined by India. Only based on the production, based on the demand only, we can extract this thorium. So China global production, this monazite 95%, we can observe here. So which products require rare earth elements as raw materials? So we can see superconductors, refining, catalysts, cell phones, windmills, hybrid car components. Already we have discussed. So these are required raw materials. Rare earth materials we can use by separating different elements, but without separating. That means raw materials we can use for all these things. Raw material of rare earth materials we can use for superconductors, which has a most demand in the present situation. So refining, catalysts, cell phones, windmills, hybrid car components, electronic polishes, and high flux rare earth magnets. And all these direct rare earth elements can be used. Raw materials can be used. So without any separating the materials, we can use the raw materials. So a few typical applications of rare earth materials, let us see. So electronic devices, if you observe for the electronic devices, smartphones, so global positioning system, GPS, now we are using this GPS. It is very important in our daily life. So for this also we can use these rare earth materials. And color display, rechargeable batteries, hard drives, all these all these are the applications for rare earth materials in the electronic devices. And advanced communications, already we have seen GPS, space satellites, communication systems, signal amplification, and fiber optic cables. So these are the applications in the case of advanced communications. And clean technologies, solar energy, electric cars, hydro energy, and wind turbines, fuel cells. So these are the applications in clean technologies. Healthcare. So these elements which are used in the health, X-rays, drug treatments, lasers, MRI, neuroradiotherapy, and all these which are the rare earth elements we can use it in the healthcare. And defense also we can use. So missiles and protection, anti-missile defense, aircraft parts and jet engines, communication systems, electronic countermeasures. So in defense also these materials are used in these particular areas. Let us see the individual elements. So use of rare earth with respect to the individual elements. So here these are the ceramics 5% and phosphorus 9% we can use. Metallurgy we can use rare earth elements 9%, and glass industry 21% are used. Catalyst 21%, and magnets we can use 20% of the rare earth elements. In alloys we can use the 9% of rare earth elements. And use of rare earth materials with respect to the individual elements. So mostly we can see cerium, which is 33% of these elements can be used in the present days. Even though we have 17 elements, cerium, which is most widely used, up to 33% of cerium can be used in our daily life, based on the demand. And next goes to the lanthanum, 30%, and next neodymium 18%, yttrium 9%, and chromium up to 7%. And all these different elements almost very less when compared with the cerium. And news. Let us discuss the news which are related to the rare earth elements. Already we have discussed China, which has the ban because of it gets up to the weaponized rare earth dominance in the trading. So it has a ban, and because of this ban of China to export the rare earth elements, almost we have a partnership with the Indo-Australian strategy, because Australia, it also can be supply after this China. It also has most of the rare earth elements they can supply. So after the ban which was China got, so we have a partnership with the Australia. And advantage of these rare earth materials, present scenario, we can see nanoscale devices for analyzing brain chemistry. So if you use the drugs, so it can pass, the drugs can be passed throughout the body. But if you use this material which is made with these rare earth elements, so it can see only the problem, it can identify only at a particular problem. So much smaller and more accurate sensors are needed to address the long-standing problems in the biomedical research, such as tracking the distribution of drugs throughout the body and monitoring brain chemistry. So this is the device which can monitor these drugs throughout the body and monitor the brain chemistry. So this is also very important device nowadays which come into existence. And we can dope these rare earth elements in different materials. So we can dope in the nanomaterials, and we can dope in glasses, and we can dope with crystals. So out of those, already I have prepared these prepared rare earth doped nanomaterials in as a single crystals. Just I will show you. So by doping these elements, it exhibits the luminescence properties. And I have chosen europium. I have chosen so many materials. So out of those, europium also one of the best material with atomic number 63. And this europium, it was first discovered by the scientist Eugene Antoine Demegrassi, and he discovered this element in the 1901. So the main ores which contains the europium, which are already we have discussed, europium we can extract from monazite, which was abundant in the India, and europium can be extract from these also, plasmasite, and these are the materials which we can extract the europium. And current news. So recently we have the nano robots which can fight with the cancer. So this is very important robot. So recently it was came into existence. So cancer fighting nano robots can destroy the tumors. And I have published the paper which was europium doped L-histidine hydrochloride monohydrate single crystals, and which exhibits the luminescence properties. So with this, I conclude the rare earth metals, which are very important in our daily life. So which we can see the wonders and miracles in each and every technology. We can see these rare earth materials, even though in our medical defense or in device electronic devices, all these things, these rare earth materials can replace, and which have abundant applications in our daily life. Any queries?
Thank you so much, madam, for the wonderful presentation.
Thank you, sir.
Now it's the time for discussion. Dear participants, you are requested to come with your queries. If you have, please come. Dr. Sanam Shukla, sir, please.
Thank you, sir.
Good evening, Dr. Bedkar sir, Principal sir, Prashant sir, and thank you very much, ma'am. Wonderful presentation. This is a very new topic for us to understand. And what the name suggests, rare earths means I thought that it must be in a very small places in the earth, but it is not so. You'll find that it is not in abundant form throughout, but it has been spread throughout the earth. That is what you have said. Wonderfully explained. And yes, definitely some of the names are familiar, some of the names are very new for us.
Yes.
Yeah. And some of, I think the substances, maybe some of them may be terrestrial and some may be atmospheric, they may be in the form of gases also.
Yes.
Yeah. And you were talking about what is that? Theron, no? Radioactive substance. Radioactive substance.
Thorium.
It is available on in the rocks of the Kerala, rocks of Kerala. And I think some radiation is being emitted by these rocks also. So definitely it is there. It is a part of our life. And yes, definitely we can use them in a various field. You said about the health sector, and definitely for screening of brain and activities of the brain functions, we can use them. I remember one of these substances used for the astronomers or the people who are going in space.
Yes.
They are also using this kind of material because they are very light in weight. I have read some paper somewhere. So thank you very much, ma'am. Ma'am, one question is there. Every substance has a positive side and negative side, toxicity. So can you elaborate on the toxicity side? Because many of the times we are dealing with the substances, but we lack the knowledge. Which dose can become lethal, or which lower dose can be a betterment for the human being. So can you point on comment on this side, madam? Thank you.
Yes. Actually, if you use the required percentage, so it gives wonders. But if you use more than that, that means here I have doped this rare earth material, single crystals with europium, and if I use less amount of percentage, I didn't get any application part. But if I increase slowly, I got very good results which can detect the radioactive rays by using those single crystal, and we can identify the rays which are present over here. I can observe. But if I use much more that percentage, so here we did not get any result, but we can see some not good. That means we didn't observe any good application. And I don't know. Actually, we did a simple application part only, but with those things we have to go for another characterization technique so that we will obtain the whether it is good or bad. We don't know, but based on this material percentage also, we have some good things, that means positive, and based on negative also. Even though these can be detect these rays luminescence properties which exhibits, it can applicable only for some of the applications only, but sometimes it may harms also. And we can see already have discussed about radioactive thorium. We cannot store it, that because of its radioactive property, but it has a lot of advantages and also disadvantages. Radioactive materials means which has more radiation also. It exhibits more radiation, which is very harmful to us.
Ionizing radiation, they get deposited in the human body also.
Yes. So even though while we are doing this research also, so many particles we can inhale unknowingly. So that is also disadvantages. While we are going to do some research oriented, we don't know exactly what the material has, which property it has, we don't know. but sometimes it may get some harmful also. So those are so many.
My one more question is there. Are they are a part of human body also? Are we getting this kind of
Yes.
elements
Yes,
in the human body, and is there any specific role for this?
Yes, sir. Because rare earth elements up to now I don't know exactly, but each and every material has different properties. And even though if we have any problem, that means some of the cases they are giving with gold or medicines. If we are inhaling the medicines we are taking, we have iron tablets, calcium tablets, gold those already we know, but we don't know exactly the elements which are present in this periodic table. Universe contains all these elements, but we are using some particular elements only we will use, and we know only some of the elements. We came to know about their existence because for pregnant ladies they are offering the iron elements, iron tablets, and calcium for bone strength. We are using calcium, and like that up to now I don't know exact in which medicine, but they are using these elements in sensors which can kill the tumors in our body. Already I have discussed, no sir, current news already just now I discussed these elements, the sensors which nano robots can fight with the cancer and destroy the tumors in our body.
Yes, ma'am. Perfect. Thank you very much for your great explanation, ma'am. Wonderful study you have made. And ma'am, my one last question is, after 1960, we could not get any kind of element. That is what your statement you have made.
These
So
rare earth elements,
55 years, why we could not get it? The people are not searching it, or we are not really getting it. What is the problem?
Actually, the name also which was given after the scientists, maybe they identified, but the name already they are used. We came to know the rare earth elements after 1960s, and 65s we have a lot of applications in lighters and in different categories we have used. I think they know these elements, but the name, I think the name which was not given to these elements. So after the elements which are present in a particular village, also we have given the names scandium, yttrium, like that, or after the scientist names only, because maybe already they may discovered, but they are not came in the lively, they cannot display.
Yeah,
the one cannot be recognized. Maybe
several meteoroids are also visiting our planet. So, are we getting some new metals or elements from those?
Yes. Yes, sir. Yes, sir. We will. There is a hope to get maybe more elements we can, based on the research, sir, and also the elements, and these should also be accepted by our government also, no sir. Lot of research is happening, but only some of the materials or some of the research only come into live, but not each and everyone's research is not coming into real world. If you see, a lot of research has been done, but maybe new elements may also exist, sir. They also should accept at our um, global level also.
Doctor,
thank you.
What is the event? If you have, please come ahead. Vidyanath Jha, sir.
Sir.
हेलो, नमस्ते मैडम, सभी को नमस्कार। मैडम, मेरा एक सवाल है कि जो अर्थ मटेरियल है व्यक्ति से जुड़े हैं, तो मैं तो यही कहूँगा कि व्यक्ति पूरा अर्थ मटेरियल से बना है, मेरा ये सवाल है कि जो हमारे लाइफ के लिए अर्थ मटेरियल बहुत ज़रूरी है, क्या ये ख़त्म होने की संभावना है और कब तक हो सकता है? ये सवाल है मेरा।
Sir, I don't know Hindi much more. Can you please translate in English? Anyone?
Jaivir Singh sir, please repeat your question. I will translate.
प्रशांत सर, मेरा ये कहना है कि जो अर्थ मटेरियल है जो व्यक्ति के जीवन के लिए बहुत ज़रूरी है, जैसे कैल्शियम है, ये सारी चीज़ें हमें मिलती हैं, तो उनके ख़त्म होने की संभावना, जैसे खुदाई हो रही है हमारी, तो उनकी कितनी संभावना है ख़त्म होने की, और क्या कोई इसका पीरियड है ख़त्म होने की, कि कितने समय में ये ख़त्म हो जाएगा?
Madam, the question is like this, the rare earth materials is very important to the life, but nowadays it vanishes, disappears. So what are the reasons behind that? Or how much time yes, please, ma'am.
Yes, sir. Actually, rare earth materials, they are not rare. Already in the first slide itself, I told you, they are existing throughout the world. And but the material, they are a mixture of different combinations. And also one more thing, these because we cannot extract these materials because it is very difficult, and so many reasons we have. Even though if we extract these materials from this ore or alloys, we cannot store in a particular material. That's why mostly production, we have to make the production by extracting the ores or from separate the ores from one material to another material. And it is the global production, it is when compared with, already I have shown you the graph, the production, it is very very less throughout the world. Only China is forward in extracting or these production of these rare earth materials. See, if we see, even though we have different kinds of countries we have, even India also, we are not doing much more extraction, only 1.23% only. But China only, it extract more production. So it is very difficult to extract, and I think these rare earth materials may exist more time when compared with other materials like petrol, diesel. What we are thinking, like they may in future, which we cannot which we cannot have this petrol or diesel because we are using much more quantity. Like that, we are listening all these words, but these rare earth elements, it is demand is more, but extraction is very difficult. Maybe it takes more time to disappear or vanishes these materials, because the production is very very difficult task. Even if you want to buy 1 gram or 0.5 milligrams, it takes around it, some of the materials, it costs up to 10,000, 20,000. Even European or and other materials we have, for research we have bought with a high cost. So most of the people, they cannot use these this much of cost they cannot use. That's why the extraction also very less when compared with other elements. Suppose if you see other transition metals or transition elements, they are very low cost, and we can use more when compared with these rare earth elements. So at present, we don't have this much of trouble or problem which vanishes or disappears, and as per my knowledge.
Thank you, madam.
I am Vidyanath Jha from Darbhanga, retired principal of a college. I have sent one of my papers to the principal, Dr. Bedkar sir, and that is in relation to science in ancient Indian maxims. And it is requested that within a week's time, it would be possible for me to deliver a PPT lecture after about a week. So you can fix the program accordingly. I have sent the paper on your personal WhatsApp. I will wait for the schedule. Yes. About 30 to 40 minutes lecture, I would like to deliver.
So thank you.
Thank you, sir. Thank you, sir.
Thank you so much, Dr. Swami Shukla sir, Honorable Jaivir Singh sir, for your nice queries. Madam have answered it very well. Now I request the chief organizer of the series, the ideal principal of Shri Kumarswami Mahavidyalaya Ausa, Honorable Dr. M. Bedkar sir. Please come sir to conclude the session.
Thank you.
सर मुझे एक चीज अच्छा लगा सर, मैं टोकना चाहूंगा यहाँ पे। मैम ने इतनी अच्छी जानकारी साझा की। मैं फिजिक्स का स्टूडेंट नहीं हूँ, मैं साइंस से मैंने हमेशा पीछे भागा है और मैं आर्ट्स का सब्जेक्ट कर रहा। और मैम क्या बताऊं, मैं साइंस से मैं हमेशा भागते आया, साइंस और मैथ से। और यही वजह रहेगा कि मैं पत्रकारिता का विद्यार्थी बना और उसके बाद मैंने कभी फिजिक्स केमिस्ट्री बायोलॉजी ये सब खोलकर पढ़ता नहीं था, जिसके लेकर काफी डांट भी लगता था, क्योंकि हमारी बहन लोग को साइंस से रिलेटेड पढ़ाई कर रही थी और मुझे कोई इंटरेस्ट नहीं था। मगर आपने जो बताया है ना, वो बहुत ही, पता नहीं, मैं ये समझ रहा था कि समझ पाऊंगा या नहीं समझ पाऊंगा, मगर मैम का प्रेजेंटेशन इतना मतलब व्यापक स्तर से था। और वो भी एक इंटरनेशनल न्यूज को भी उन्होंने दिखाया प्रेजेंटेशन में। वो ऐसा न्यूज जो कि हम उससे अछूते थे। कम से कम मैम के माध्यम से ये जानकारी मुझे मिल पाए। बहुत बहुत धन्यवाद मैम। और ये फिजिक्स से हमारी आज थोड़ी सी रुचि बढ़ी, इसके लिए बहुत बहुत आभार।
Thank you, Dr. Swanand Shukla sir, Dr. Jaivir Singh sir, Vidyanath Ji Dha sir, for your queries, and also my dear friend सोनू कुमार सर. सोनू कुमार सर, मैं एक बात बोलता हूँ कि जैसा साइंस के स्टूडेंट्स भी उनके दिमाग में एक फोबिया रहता है फिजिक्स के लिए, आप तो आर्ट्स हैं, आप आर्ट्स कॉमर्स पढ़ने वाले बच्चों को तो काफी रहेगा, मगर जो साइंस में एक्चुअली पढ़ते हैं उसके लिए भी एक बड़ा फोबिया बनकर उनके दिमाग में रहता है, और सबसे डिफिकल्ट सब्जेक्ट बोल के वो दिमाग में बैठा हुआ है. मगर अगर स्टडी करे ध्यान से तो everything is possible in the world, nothing is impossible. So thank you so much. Now I move towards the vote of thanks. Mahavidyalaya Ausa District Latur in Maharashtra State, it's organized this World Record Series 2. It's a daily webinar series. Today we have completed 364th day, and the topic was very interesting and the important one, that rare earth materials and its application in daily life. Now this topic have presented very nicely, clearly in a simple language by today's keynote speaker, Dr. Seelam Rajyalakshmi ma'am, where she explained all those details, covered each and every aspects. The PPT was perfect, and the way you expressed, madam, it was so sincere and excellent one. You covered all the details regarding the topic, that periodic table of elements, why are the rare earth elements given their name, then different types of rare earth elements, as well as the global production on the demands and nanoscales device for analyzing, and at last doping of rare earth elements. Now each and every details you have put in front of us. So thank you so much on behalf of the organizing committee members. Very nicely you talked, madam. I express my sincere gratitude towards you. You have paid your valuable time to the series and delivered a nice lecture. Also thanks the chief organizer of the series, our principal, Dr. M. Bedkar sir. Thanks the colleagues from my college, IQAC coordinator, Dr. Sanjay Kale sir. Special thanks Dr. Swanand Shukla sir, Dr. Vidyanath Jha sir, Jaivir Singh sir, and my friend Sonu Kumar sir. And I should not forget to thanks all those dear participants who join the series regularly, encourages us. So thanks a lot to you all once again. Now kindly request to you all, please fill the feedback link which is given in the chat box. So with the kind permission of the chief organizer. क्या बात है.
थैंक यू सर.
थैंक यू सर, थैंक यू.
ढेरों बधाई हो सर जी आपको. और वो दिन मार्च का
मुझे
याद है, जब 8 मार्च शायद मार्च के महीने में शुरू हुई थी दोबारा. तो आपको बहुत बहुत बधाई हो, और प्रशांत सर आपको भी, कि ये कारवां आपने भी आगे बढ़ाया है. प्रशांत सर की बहुत बड़ी भूमिका रही है कि जो एंकर के रूप में इन्होंने ख्याति प्राप्त, वो जन जन में पहुंची हैं, और हम बहुत ही तारीफ करते हैं, क्योंकि इनका जो अंदाज है आमंत्रण देने का और धन्यवाद प्रस्ताव देने का, वो अलग ही अंदाज में इनका रहता है. आपको भी बहुत बहुत धन्यवाद
सर. डेली स्टाइल ये है जयवीर सिंह सर, डेली स्टाइल है, शायद सबको बोर लगता होगा, मगर इट्स माय ड्यूटी टू जस्ट इंट्रोड्यूस द स्पीकर. आई नोट ऑफ थैंक्स. I request participants please not to get bored of my talking every day. The same things I am just expressing in front of you. So there is no change in my talks, etc. Thank you. Thank you.
Thank you, ma'am.